Okay, so with topic 5 down, we're able to start topic 6. So topic 6, if you look at our website, it's called histograms. Okay, so that's another way to visualize data in a sense that it's really useful, and I'm sure you have seen this kind of examples in other outlets as well. But in order to understand how to make histogram, it has a few important terminology as well as concept, as well as understanding what histogram is about. So we're going to start that journey now. And like I said, histogram is a way to visualize data. And in particular, you will see that it's a way to visualize numerical data as well. Okay, just like the ones that we have seen. But like I said, in order to understand it, we need to have certain terminology, making sure that we understand everything. So we're going to start with that. Okay. So I think we have seen this a lot already. For us, I just want to make sure that we have a solid understanding of all of the terminology about tables, okay? And then from there, we can start to talk about what we mean by distribution. Okay? So when we have a data table, okay, remember we have those columns and the rows, okay? So each row, like we said, is a record or is an individual, okay? So for who, in this case, for those whose features are recorded, and they're gonna represent rows in the table. The variable, okay, represent each column in the table. We call it a variable, but it can think of as a feature, attribute, or information, like one piece of information about each observation, okay, and they are the columns in the table. So variable, for example, earlier in the movie data set, or like the actor data set, right, we know the name, so name is a variable, right? It's a column, and then it's a variable in our terminology. And then we also have the gross total, right? That's another variable, and that's another information about each observation. Okay? So one thing we need to mention, and I think we all probably know this already, but it's important to highlight that a variable can have different values. Okay, that's why, like say for the name, well, each actor has a different, or actress has a different name, right? So that is a different, like each row is actually different there. And then for total gross, well, it could be that one or two or three or more actor or actresses have the same total gross, but more likely or not, I think it's going to be different. So that's another illustration of a variable has different values depending on which row you're working with. Okay. The third thing here, as you can see, is that the values themselves, okay, can be numerical or categorical or many of the subtypes within this. Okay, so based on the way that we're presenting here, you see that we're pretty much having two biggest categories of values or variables. Okay, one is numerical, the other one is categorical. Okay, this is the biggest, like the top two, like top level distinction, the categories. Numerical, like say year, or like age, year, or like the total gross, they are all numerical. Categorical, meaning that they're just categories. Okay, like I think like ice cream flavor, for example, that's a categorical variable. Okay, and what else? Categorical, like gender, for example, depending on how many levels you have, that could be another categorical variable. Okay, numerical, like I said, we have examples of year, age, and then total gross, but all of them are slightly different from each other if you start to recognize their differences. Like age typically is coded in the nearest integer, right? So it's unlike like a total, like a gross, for example, that you can have multiple decimal points depending on how you're recording the data. And that's what we mean by subtypes within this. Okay, so for categorical, for example, like the gender one or the ice cream flavor ones, there are what we typically call unordered categorical data. Okay, there is no ordering among the different categories, but sometimes you might have a categorical data that has an inherent order. For example, if a survey asks you how did your last week go, and then maybe for that survey question there could be like 5 different choices, like really bad, bad, neutral, good, very good. Okay, so that will be an example of a ordered categorical variable. Okay, so just keep those in mind. Okay, for visualization purposes, I think that we don't make too much distinction per se. Like numerical, we have certain visualization methods to do. Categorical, we have certain ones to use. But for our own understanding, as well as like trying to understand the table, as well as like the data set itself, I think it's very important to recognize that there are subtypes within this, and then we have a clear understanding of the different subtypes depending on which variable we're working with and what kind of visualization, what kind of like analysis we want to do later on. Okay. So lastly, each individual has exactly one value of this variable. Okay, so that's why like in the table, as we can see, that we have each row as individual, multiple columns, right? And then for each column, let's just say for the ice cream flavor, for each observation, I cannot have two flavors at the same time. Well, for that example, right, you can of course have two. Like if you want to have two scoops, so one is strawberry, the other is vanilla. But you know what I mean? Like the flavor, in terms of that definition, the example that we saw a few weeks ago, that's where we have the example of exactly one value of that variable. Okay. So with all of this cleared up, hopefully, now we can start talk about distribution. Okay. So right now, let's just understand distribution of for each different value of the variable, like the frequency of individuals that have that value. Okay, so in the ice cream example, if you remember, we probably have like three rows of chocolate and then 2 rows of strawberry, things like that. So that frequency that counts, okay, of the different values of the variable will be the distribution that we're looking for. Okay, and then of course, the visualization, any visualization that we're doing is trying to give us a sense about that distribution. Okay, so keep that in mind, okay? Let me show you how we can do visualizations for categorical variables. And from there, we're gonna move to histogram, which is typically used for continuous numerical variable, okay? So let me start with a demo. I think that's probably more illustrative, and then we can come back to those summary. Okay. All right, always make sure that we run the first cell because all of the necessary libraries are there. Okay, so we come back to this table of the data set of the top movies. Okay, remember we have 200. Okay, 200 in total, the top 200 movies in 2017 in terms of the gross adjusted. Okay, so among all of the variables here, okay, last time, just now, we looked at gross or gross adjusted in particular and year sort of. And then the title, okay, one thing about the title here is that indeed, I would say it is a categorical variable, but because it's a title of the movie, so we know that it's going to be 200 different categories here, right? So it might not be as interesting to look at. However, the studio column, actually, you can see that Star Wars and Sound of Music both were produced by Fox, right? MGM did Gone with the Wind, and then Dr. Shivazo, and then Disney did other ones, things like that. So it might be interesting, at least I'm interested, I guess, for the top 200 movies in 2017. I want to see the breakdown of the studios who made them, okay? And if I go for that, just see how we phrase the question. While we're looking at a categorical variable studio, okay, we don't know how many categories yet because we know that it's just going to be like a list of studios producing this the top 200 movies, okay? And then if I start to ask the question of, I want to see the breakdown of how the studios are doing for the top 200, essentially what I'm asking is, I want to look at the number of movies out of this 200 is being done by each studio, okay? When I say in that way, if you look at what we're trying to use the definition here, sorry, over here. Yeah, maybe it's not here, sorry. I probably jumped to a different slide, but what I'm trying to say is that we're looking at the distribution of it, okay? And we know that the distribution is a frequency, sorry, it's here, I guess. Yeah, for each different value of the variable, we are curious about the frequency of the individuals have that value, just like the way that I am right now, at least interested about that video, about that studio's column. Okay, so let's see how we can do it, okay? One thing we could do, well, maybe just get started, is that we know that we're interested in that particular column. Okay, so how about let's just like get that column, okay? So to get that column, we're using the select method. Notice that here, I'm not doing column. If I do dot column, it becomes an array, right? If I do dot select, it would just become another data point. It's just another data table that I can keep manipulating with, okay? So the biggest distinction now, I guess just to highlight again, we talk about dot column to select a column to make it as an array, and then we can do arithmetic about it, okay? And we do dot select to select a column or multiple columns, but here we're just selecting one column. So the outcome of this, once I do the selection, is still a data table, okay? And the reason why in this case we want to do the data table is because we know that a lot of the methods that we have covered so far actually can be applied to data tables. Okay, that's why we want to keep it as a data format. Okay, earlier when we were trying to turn, if you remember, this gross adjusted variable into millions. Okay, there we know that this is a numerical variable, right? And we know that in order to turn it into in millions, we have to do arithmetic about it. Like we have to divide it by 10 to the power 6, and then do certain rounding and things like that. So that will give us a hint that for that kind of cases, we want to do dot column because we want to make it into array and then do the arithmetic. Okay, so here we're doing the dot select. So the outcome, the final product here will still be a table, and then we can keep doing table methods on this particular variable. Okay, okay, all right. So now today we're learning something new here. Okay, we're working with the studio table. And then the column name is studio, okay? So the method that we can apply to a table right now to get the counts of each levels of a categorical variable is the dot group method. Because look at what we're doing here. Studios, okay, is the new data table containing only the column of studio, okay? And the method is called dot group, okay? And it's being applied to a table, which is the studios table. Okay, the input right now that we're having here is one input. It's just the name of the column. Okay, when I do that, I'm pretty much just asking Python to give me the breakdown or the frequency. Okay, more formally, like the frequency of the observations that are sharing that particular level. Okay, and notice that I like assign it to something else. So later we can also work on that if we want. So let me run these 2 lines for you. And now you can start to see what this dot group method has done for us. Okay. So we assigned it to a studio distribution. Okay. So we started off with studios, which only has one column up here. Okay. Just all of the rows of the studio. And we know that it's still 200 rows of them. Okay. Because what we did is really just selecting that column. Each row is still represent a movie, even though now we get rid of all of the other information only about the studio. But the dot group method, as you can see here, is turning into this data point, this data table into a new data table. Okay, we call it studio distribution, so we're able to see it. Okay, but interestingly here, if you look at it, now we don't have 200 rows anymore. Okay, we have, I don't know how many, we can count it if we want. But essentially, once we do the dot group method, what this is doing for us is that we're having a new data table where each row represents a level or like a category of that studio variable. Okay, we have the name of the studio as well as the count out of the 200. Okay, so the number of rows here, well, will just be the number of distinct studio names appeared in that top 200 movies data set. Okay, and the new column count, well, that's just like by default, that's the name. So later, if we want to work with anything about the count, we're going to do select that column name. Okay, it's just by default, it's called count. So we're able to do other, well, maybe you want to do visualization, or like, for example, here, it might be a good visualization to do, right? Like do a bar chart, for example. I want to look at all of the studios and then look at their accounts. I want to compare them, maybe decreasing order, increasing order. So that would be actually a natural thing to do, I would say, when we get to this point, okay? But just so way to double check that we have done everything correctly, remember, there are total 200 movies together, right? And then now we're doing the dot group method. So we create a studio distribution, and we have this count column, which is recording the number of times the studio, like the number of movies each studio has made. Okay? So if we do a quick sum of that column of count, we should get back to 200, okay? Because they should simply add up to the total number of movies that we started with. Okay, so this is a quick sanity check, okay, just to make sure that we did everything right, okay? And indeed, it turned out that when we do the sum of that column, okay, we're able to get back to 200. Okay, so here again, notice I'm using the dot column again because I'm returning an array and then I'm taking the sum of them. Okay, so like I said, I think as we work more with tables, especially like different uses of the column depending on what your goal is, I think we will start to make a better distinction between the dot column and the dot select. Okay, really depends on what your goal is. I think you're going to choose one over the other. All right, I was already saying that, okay, if I have this studio distribution, maybe one thing I would do is to make a bar chart. Okay, so let me do that. And this would just give us in the order, actually, I think it is alphabetically according to the first letter of the studio name. Okay, so this is listing. Okay, so again, this is a reason of, I guess, a good example of why we want to use the horizontal BARH instead of just bar, because you're going to have like unit. As soon as you have names, I guess, you really want to plot it on the X, on the Y side in this case. Okay, so this is, well, one quick visualization if you want to do it. If I want to just see overall how the number of movies per studio are being are able to make to the top 200 in 2017. Okay, so this, if I don't do anything about it, it would just, like I said, being plotted in the order of the studio distribution. And actually by default, I guess now we know that by default, the rank, like the order, really just the alphabetic order according to the first letter. Okay, but we know now, I think, that, well, maybe instead of just like alphabetically, I want to see like the top from the bottom. Okay, so one thing we could do is remember the count. This is a numerical variable. Okay, if it's a numerical variable, we are able to sort it like decreasing or increasing order. Okay, so one thing we could do is the dot sort method. Okay, so notice that we are actually chaining multiple methods at the same time. Okay, so this is a really powerful thing I think Python has, that we are working on this table, right? Data table. Okay, I want to first sort it, sort according to count of a decreasing order or descending order. Okay, and then once I have this new table, which is sorted according to count, I want to do a bar chart. Okay, and you can do all kinds of chained methods, as you will see, either in the demo and later in homework and lab. And I will encourage you, if you think it's too complicated to combine everything in one line, feel free to break it down one by one. Totally fine, as long as you make sure that you assign it to a new object and then you're using it correctly. Once you get more familiar and comfortable with all of this, you can chain how many number of methods you really want, as long as you have a clear idea for what you're doing. So here, I would say we do have a clear idea because we want to sort based on count first, and then we want to create a bar chart based on the sorted version. Okay, so that's why the order, right? We sorted first and then do a bar chart. And now finally, it's going to give us what we wanted in the first place. Okay, we want to rank, okay, the studio from the top to the bottom according to the number of counts or the number of titles that they're able to produce, which made to the top 200. Make sense? Make sense? Yeah. And we can also do, if you guess, maybe some of you are guessing already, you can sort according to descending order, or you can sort it not according to it, like in the ascending order. I think if we do false, that will give us, maybe not as interesting, I guess, because people usually want to look at the top one first and then looking at going down. But this is just a quick example of showing that you can sort it in the ascending order and then do a bar chart. Okay. And I would just say that because, again, the names of the studios are quite long over here. So regardless, I think it might not be a good idea to do bar instead of bar H. Okay. So this one, I guess you can still see, we can see the trend, of course. We know that it's going to be going down, but it won't be able to plot all of the, or like show all of the studio name over here. Okay. And like I said, even if we try to adjust the, I think adjust the font size, it still might be really hard to read. So I think a lesson for us is that whenever we're working with a categorical variable, like with so many different categories, as well as like the length of each category is quite long. If you want to do a bar chart, you really want to do it in this way. Okay. Make sense? Make sense for categorical data? Okay. So, like I said, bar charts, very useful to visualize categorical distributions. And in particular, I would say that is one categorical, the other one is numerical. Okay, the categorical here, in our case, is the studio. Okay, and the numerical is their count after we're able to use the dot group method to get the count. Okay, so just to review for us, The distribution of a variable describes the frequency of its different values. Okay, it's really about the different frequencies here. And the group method, okay, will be able to count the number of rows of each value in the column. Okay, in particular, the group method, I would say, is really being used for categorical data like Studio. Okay, if it's a numerical data, well, it might be too many different levels, even though it can be recognized as a categorical, but it might be really hard for us to visualize later or like to get any useful information. Okay, so bar charts can display the distribution of a categorical in this case, one bar for each category. Okay, length of the bar is the count of individuals in that category because we use the dot group method to achieve that. And then you can choose the order of the bars, meaning that you can use the ascending or descending order depending on the goal. Okay, like I said, maybe most likely people would do the descending just because that's how people usually talk about like the top, like just say top 20, not top 20, I guess, like all of the studios, I guess, descending order showing the number of movies that they have made who are in the top 200, then most likely people will go this way. Okay, and I think we also talked about like the bar H and bar, depending on which direction you're doing it. And for most of the examples that we have seen so far, I would say that it's the bar H that is preferred, just because the category, all of the categories in that categorical variable have very long names, okay? And then in order to visualize that, we want to put it in an easier to read order and then a format, and that we're able to put it on the Y side, and then each of the length of the bar is showing us the numerical information. Make sense? Make sense? Okay, sounds good. And like I said, feel free to start looking at later doing the demo yourself and then doing the homework. And I think that will help solidify your understanding. Okay. So the next topic, we're still in the realm of doing histogram. We haven't talked about what a histogram yet, okay? But let me just say that the bar plot that we've seen actually already tells us a little bit about how a histogram will be constructed in the end. So let's go about it. So the bar plot that we see earlier, we were saying that it's useful for doing a categorical variable, right? And in particular, we use the dot group method, put it into a distribution about like not only the levels, but as well as the number of counts according to each level. And then we're able to use a bar plot to visualize it, okay? So for numerical data, so far, if you remember, we have seen how to do a line graph, okay? We have seen how to do a scatter plot, right? Especially if we have multiple numerical variables to visualize. Another thing people typically do is that, well, numerical variables, for example, like the total, like the total gross total, for example, like in millions, let's just say the gross adjusted in millions, okay? Sometimes maybe I don't want to show them in a scatter plot. Sometimes I actually, maybe I want to see that, well, what is like, say, what if I want to see the distribution of like gross in millions, like 0 to 10, okay? And then maybe like 10 to 20, okay? 20 to 30, et cetera, et cetera. So I'm still trying to understand information about this numerical variable, okay? But in particular, in order to make that happen, I have to do certain kind of binning, because I'm trying to now figure out, like, say, I have all of like 200 in total, right? 200 movies in total, just say. But then instead of just showing as a scatter plot, a bar graph to show how, like a line graph, sorry, to show about how their distribution is like about the total gross, for example. Maybe I want to look at for each particular interval, I want to see how many there are, like percentages and things like that. Okay, so that's another way to visualize this numerical variable. And the way that we're going to do it, as you will see, is a histogram. Okay, it's going to work very similar in a way like the bar plot, whereas the bar chart or bar plot, like the category is already given for you, right? You only need to do the dot group method and then you get the counts, and that's easy, okay? However, for numerical variable, as you will see now, we actually first need to create those bins, and then we're ready to get those numbers, like the counts in each bin, and then we're able to visualize it. So that's what I mean by there are multiple steps in between of thinking about like doing visualization for numerical variable, and finally being able to do it through a histogram, okay? Because it does have this, like I said, multiple steps in between to figure out how we can actually get to a histogram, okay? So at the end of the day, you will see that histogram is also showing us frequency, okay? But it's showing us in a particular way for numerical variable, okay? So in order to get us there, let's start talking about how to bin a numerical variable. Okay, I was already talking about, like, say, maybe why we want to do it in the first place, but let's see how we can actually do it for a toy example over here. Okay. All right, so binning numerical variables, like I said, we want to put it into bins, okay, because then we can visualize like frequency for each bin as a way to visualize the data. So binning, this process, is counting the number of numerical values that lie within ranges, okay? We also call the ranges as bins, okay? So the way to create them, let's define them first. Bins are defined by their lower bounds, okay? So this is, again, just very Python, okay? It's looking at the lower bound, but not the upper bound. So what we mean by this is that later you're gonna see that when we create those bins, we're gonna label those bins, okay? So the labeling of those bins gonna be the lower bound value of that bin, okay, including that value, okay? And the upper bound is the lower bound of the next bin, okay? So for example, I'm doing 10 to 20, okay, and then 20 to 30. Then my first bin is gonna be called 10 because the lower bound, like I said, is inclusive and is defined by their lower bound. So the first one is gonna be labeled as 10. And for the second one is gonna be labeled as 20. And the upper bound of the first one is 20. It's going to be the lower bound of the next bin. Okay. All right. Without, I guess, like giving you all those like imaginary examples, let's look at the sequence of numbers. Okay. They're numerical. Okay. Let's just take those values as height in centimeters. Okay. 188, 170, 189, 163, 183, 171, 185, 168, 173, okay, and dot, 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 okay? Let's say now we're trying to bin them, okay? Meaning that we're creating bins that we're able to put each of the numerical value into one of the bins, okay? Let me just say that we're doing this 1, 2, 3, 4, 5, 6, 7 bins, okay? 160 to 165, sorry. And then 165, sorry, 165 to 170, okay, and then 75 to 70 to 75, 75 to 80, 80 to 85, and then 85 to 190. Okay, that's sort of like the end of all of the values that we have over here. Okay, so if we now put everything into the bins, okay, 188 should go to the last bin, okay, because it falls into that range, okay, and that's the, notice what we're writing over here. The lower bound is inclusive, so we're using the bracket, left bracket, okay? The upper bound, like I said, is gonna be the lower bound of the next bin, okay? So for this bin, 190 is not included, okay? So if I keep doing all of this, 170, okay, 170 is exactly the lower bound, right, of this particular bin, so I should put it in here, okay? Because like we said, the lower bound is included for this bin, but the upper bound is going to be the lower bound for the next bin. Okay, so for 170, it should stay here. The next one, 189, okay, not surprisingly, should go here. 163, okay, should go into the first one. 183 should go to the second last, okay? So if you keep going, then we're able to put each of the values in one of the bins, okay? And the bin counts here, like 1, 1, 3, 0, 1, 3, is actually frequency, okay? And this is how we're one step closer to creating histogram for this type of data, numerical variable, okay? So keep that in mind. Let me show you in a demo, because I think demo is usually always easier to work with in some sense, and then easier to understand, to see things in action, okay? So what we're doing, again, we're bringing back the top movies data set from 2017. Remember, we have 200 of them, okay? And let me just print it out, maybe. That's easy. Oh, that's just easier for us to remember what we're doing over here, okay? Remember, we have 200 rows, okay? Each row represents a top 200 movie, okay? And there are many numerical variables where we have over here, okay? Gross, suggested, and year, okay? For this demonstration, let's actually work with a version of like we call like an age, let's just say like an age of the movie, like how many years it has been out there. Okay. For the demo, we're using like 2019, but we can probably do 2021. Let me do 2021. Let me do one. Yeah, just not to mess up things, but this is just one way to define the ages. Okay, so I'm creating a new column. Pretty much, I want to know the age of each movie. Okay, so I created using, well, first of all, get the age by 2019 minus the year that it was released. Okay, and then I use the dot with column to attach it back to the table. Okay, so this, I think we have seen it multiple times. So hopefully you feel pretty comfortable doing this. Okay, and once we do that, well, you see the age. Okay, and the age is being attached to the original table, and then we have one additional column. And here we're going to work on this age variable. Okay, so age, we're going to take it as a numerical variable. Okay, and now let's see how we can do the binning. Okay, so the binning that we're talking about earlier in the slide, as you can see, is that, well, first of all, I need to create the bins, right? And then I need to know like from where to where I'm having my first bin, the second bin, and et cetera, et cetera. Okay, so that's actually the first step of doing the binning. Okay, and I will also mention that in this example, we are having like equal length bins. All of them are 5. Okay, but in many cases, maybe you want to do equal length, maybe you don't. It just really depends on the application that you want to do. So we're going to see actually both approaches in this demo. So in order to create bins, well, I think the first step is we need to know what is the minimum and the maximum, right? So from there, we're able to think about how we want to create bins. So the age variable that we have defined here, the minimum is 2, okay? The maximum is 98, okay? So maybe, just given this data set, maybe one way of creating the bins is have a lower bound of 0, okay? Upper bound of 100, and then picking, I guess, certain points in between that we can create our bins. Okay? So the first set of bins I'm creating here, as you will see, is that I'm creating unequal bins. Okay, I want to have like the most recent, like the 5 year, like for the past 5 years, I have one bin for that. Okay, and then the previous 5, so it's going to be 5 to 10, and then another previous 5, so I have 10 to 15, and then keep going like backward. I guess maybe I can use larger bin here. I'm using another 10 from 15 to 20. Another 15, okay, to 25 to 40, another 25 from 40 to 65, and then the last one is as long as 35. Okay, so this one, again, you can do any kind of binning you want. Okay, I'm just giving a demonstration here to show you one ways of doing unequal bins. Okay, and the way we're doing it, as you can see, is that we're making an array. Okay, we're making an array of the lower bound of each bin. Okay. So that's how, like what we're saying over here, even though in your mind, you will know that it's 185 to 190 in this case, including 185 and excluding 190. The way that we're coding in Python is that we're only going to define the bins by their lower bounds. Okay? So that's why we're able to utilize the array method, because as long as I have an array of the lower bound values, I can create my bins. All right, without further ado, let me create my bins in this way, okay? And now we're able to use the .bin method, okay? So the .bin method is being applied to a table again, but in particular, it's being applied to a numerical value of the table. Sorry, numerical variable of the table. Okay, so the first input of the .bin method is the name of the column. So we're working with age, so that's what it is. And then the second input is how my bins are structured. So if I do that and notice that I have assigned it to a bin data, okay? So if I do that, it's actually returning us very similar to what we had seen earlier with the .group method for categorical data, if you remember, okay? Back there, we're doing the .group on the studio, right? And then it's returning us the count of each studio. Here, the binning is doing something very similar. Like you can see, the output is actually a data table again, okay? Is giving us how many rows that there are, like depending on how we're defining our bins, okay? And then the first column is giving us the bin, the label, okay? Remember, it's always the lower bound is being coded for the label. The second column, in this case, by default, I think they give you like the name of the second column is the name of the variable that you work on, and then with the space count, okay? And we know that like we can always relabel a label name. So if you wanted something else, like feel free to change it. But for our case, for our purpose, for demonstration, we're just gonna keep with it. So what you can see here, okay, like I said, it's very similar to that dot group method on categorical data. It gives us the count of each bin, okay? And not surprisingly, if we sum up the column of age count using the dot column method, because now I'm doing arithmetic, remember? Whenever I'm doing arithmetic, I better work with an array. I think that's always easier. So if I do the sum, it goes back to 200, not surprisingly. Okay? It is the number of total movies out there. And then the bins are really just like when we are creating the bins and then use the dot bin method, is really just doing the counting, right? Of each bin, how many number of movies in each bin. So they should still add up to the total number of movies in the first place. Okay, so that's what we're seeing over here. Make sense? Make sense? Yeah, one thing I want to bring your attention to here is that, well, there's always like one extra bin, as you can see over here. Okay, it is, as you know, if we make an array like this, it's going to give us, so remember, this is the lower bound of the current bin, right? But then in our case, because the maximum is 98, okay, so it's not surprising that there's no count for 100 and up. Okay, so that's why there is a 0 over there. Okay. All right, of course, there are different ways to do binning. Okay, let me show you, like say this one, for example, remember our old friend .arange. Okay, we start with the beginning, going up to the end, right? And then with certain interval. Okay, so here I'm doing pretty much in this case, my bins are 0, 25, 50, 75, and 100. Okay, so I'm creating equal size bin, equal width bin here, and I'm using the dot bin method. So if I do that, you can see that I'm getting something else. Well, it's a different distribution, right? Now, because I define my bins differently, the count is going to change accordingly as well. Okay. Now I guess you start to see that maybe why in the first place that we wanted to have like a smaller space in the beginning ones and then larger space in the later ones, just because, well, there are a lot of movies made more recently that have made to the top 200. Okay, so in that cases, you might want to like have a larger, I should say like a shorter bin width, right? More bins in that range of the data, so you're able to see more features, more local features in that range, okay? But if I'm only doing like 0, 25, and 50, and 75, then it's all sort of like lumped together, so it might be harder to see. But this is just another example, like I said, you can create arrays with unequal width, or you can create array, like we know, using the .np.arrange method, that will able to give you equally sized bin, and then you're able to use the dot bin method again. Okay, I do see a quick, I think, a comment. Let me see if I can get to it. Question maybe. All right, if you create bins that don't cover the whole range, for example, the ages go up to 150, or your bins go up to 100, will it give you an error? Or will the values above 100 automatically be put in the bin with the lower bound of 100? Okay, so that's a great question. Let's just find out. So I'm going to create a new, whenever I know that I think I'm going to create a new one, I always like delete it. I made this mistake all the time. Anyway, so the question here, if I understand it correctly, let's see. So earlier, I think the example we had earlier was 0, 1, 1, right? And then 25. Okay. So the question now in the, you might not be able to see it because it was typed like directed to me. But like I said, if the bins that we create do not cover the whole range, but our bin only go up to like something lower. Okay, actually, like I guess whatever I left over here is a good example here. Okay, so here the bins, right? I'm creating the np.arange of 0 up to 60. Okay, so clearly I'm not covering like the upper ones, okay? But I'm doing like with the 25 interval using the .arange method, okay? Let's see what we find out. It won't give us the error message per se, but it's not gonna give us something useful either. Okay, so see what's happening here. One thing immediately we notice is that, well, it's gonna end at 50, right? Because the way that we're creating the bins, it would never get us further, okay? However, one thing you will notice that if I add up these two numbers, clearly it's not 200, okay? Something is missing here, okay? So this is actually a good example. I guess it's a really good learning example of knowing, well, it's very important to create your bins correctly, okay? And then whatever, like if
Professor,
yeah, go ahead.
you're not sharing your screen anymore.
Thanks. Let me do this here. Sorry about that. Okay, let me, okay. All right, sorry about that. Okay, let me see this, okay? Do you know what I mean now? I'm doing like a 60
Yeah.
as the endpoint, thanks, yeah. And then the increment is 25, sorry about that. Okay, so what I mean here is that, okay, it's gonna end at 50 because that's how we like ask for it, okay? My bins here, or like bins here is mp.a range is only gonna go up to 50 because the way that we specify it, okay? However, another issue that we're seeing over here is that they do not add up to 200 anymore, okay? We know that, well, to create good bins, if we have a term like that, we really want to cover the entire range, okay? And we want to create bins that can show us important features of the data, okay? Just like when we do it over here, like I said, it might not be as interesting, right? Because it's too much in those smaller bins, like in the earlier bins, because there are too many movies made in that case, in that data time, in that period. So it might make more sense in this case to make bins. It does not have to be the same as what we did, but it might make sense to have, like I said, shorter period, like shorter interval in the earlier year, in the most recent years, okay? And then if you're doing something like what the chat message earlier was asking, that if we don't create bins go up to the maximum, okay, then it's gonna cause us trouble, okay? And in particular, well, one thing we know is that, well, they're like, it's very surprising, right? Like they don't even report any count above 50, even though we know there is a 50 over here, okay? But this is really like, say, we can also do the .where method, right? Like, are there any movies with H50? There are, like, we know there's one. So at least this should not be 0, right? Like, again, what I mean is that we really want to create bins in the correct way, okay? And a lot of times if we do not cover the top, then it could give us trouble, like not enough information, or like showing insufficient information or missing something out there, okay? One way to understand why this is 0 may be useful is going back to this example. If you see, whatever is being ended over there, like 100 over here, well, in this case, I guess, well, there are none above 100 anyway, okay? So here, yeah, I honestly don't know exactly why it does not give us like anything above 0. But to me, I feel like a lot of times it's just the way that the binning is being done. And we want to make sure that we do have correct binning being in the right place, so we're able to return the information that we really need. Okay, makes sense? Yeah, and thank you, Gordon. I totally forgot that I didn't share my screen anymore. So, so that's good. And yeah, so like I said, binning is the first step of doing any kind of further visualization of numerical data with, okay, I see another chat. Oh, you're welcome. And yeah, so binning is the first step of doing histogram for numerical variables, okay? So now, let's start just a little bit. I know we're only having 5 minutes left, but I think it's still be good that we talk about the area principle. In particular, that we need to know this pretty well in order to understand how we're doing the binning later, especially for the histogram that we're going to create. Okay, so for here, let me just show you the area principle. I think we all know it actually one way or another unconsciously. So I just want to show it up front to make sure that we're all understanding it. Okay, so here there's a news article, okay, from Flowing Data. Okay, they were saying that this figure shows the battery size in the new iPad on the right hand side versus that of the iPad 2. Okay? And also in the text, they say that the battery in the former is 70% bigger than that of the latter. Okay, so what that is saying is that the right hand side, okay, is 70% bigger than the left hand side. Okay, so one thing, I don't know if you are like pretty suspicious here to me, I feel like, well, when they're saying like 75% bigger, the right-hand side compared to the left-hand side, it's pretty much just saying that, well, this is, I guess, talking about the battery size, okay? And then they're showing us in this cylindrical form, right? So it's really just talking about, I guess, the volume, right? The volume of the right-hand side should be 1.7 times the left-hand side, right? So if you agree with me on that kind of understanding of volume and then battery size, I think this picture will look a little bit weird, okay? Because just based on the way that they're showing it, it feels like it's much better. Like it's probably like 4 times, not like 1.7%, 1.7 times larger, okay? So the mistake that they're making here, I think, is that instead of showing the volume, 75% higher, the 70% higher, sorry, they're showing, I think, the radius, okay, the radius of it. But once you know, like the rate, like the volume formula for cylinder here is what, like what radius to the, what is it? I probably don't remember it correctly. Is pi times r squared and then times the height, right? So the effect of like 1.7 times radius actually gets squared, right? When you're showing it in terms of the volume, okay? So that's the issue here. And that gives us an important lesson, which we will see soon, not today, probably on Thursday now, of understanding a histogram, okay? So the histogram, as you will see, is that, well, the histogram, each of the histogram that were like the bar that we're able to print or like show, visualize, is talking about the percentage of the data points fall into that bin, okay? Just like what we did on that demo, okay? So, but then later, of course, remember what we did in that demo, we're doing the binning, we do the counting, and then what's gonna be important on the histogram we will see on Thursday is that what's being plotted, well, it's not only just the area, which is showing us the percentage, but also the height of each bar, okay? So that is an important lesson that we'll learn on Thursday. So to help us get that, just using the iPad example that we're showing here, the area principle is very important to keep in mind, okay? So the area should be proportional to the values that we represent. For example, if you have 20% of the population by one triangle, then we know that 40% is just 2 times of it, okay? Just like 2 triangles. But just like this example, like the mistake is made over here, sometimes people accidentally think, oh, I need to like say twice, like double the length, right? Double the length of the side, okay? But then again, according to the formula of the area of a triangle, we know that it's not gonna be 2 times, right? It's gonna be 4 times because there's a square term over there, okay? So I know this might sound a little bit vague at this point, but on Thursday, when we come back, you will see that drawing histogram, we need to make sure that each of the histogram bar is showing us the percentage of each bin, okay? And then the height of the bin is showing us the frequency, okay? So if you have that lesson in mind, you will know, and you will see that on Thursday, that because each of the bin area is the percentage that we're able to compute, then the height will have to be actually the area divided by the width, okay? So that's the important thing to keep in mind, because a lot of times, like I said, like, okay, just 1 minute. So I'm just going to go back to one example, I guess, the bar plot that we did over here, for example, this one. Okay, so this is not a histogram per se, because, well, we know this is bar chart, right? Because each bar is telling us about the millions total growth, I think, growth adjusted for each movie. Okay, so here, well, the height or like the length of each bar is already telling us the numerical information. Okay, and this is so because we're plotting against the name of the movie, right? And then for us, it's really just like the millions growth adjusted information showing for each of the numerical, each of the title that we have over here. Okay, but for a numerical variable, now we know, especially if you remember the example that we did, for example, let me see over here, for example. Okay, yeah. So like this 1, 2, 1, 1, 3, 1, 1, they are the percentages if I divide it by the total number of bins, like total number of bars over here. Okay, so what histogram, we'll see that, well, if you have equal bins, then the height is the same as the area, like proportionally. Okay, but if you don't have equal bins, then you need to be really careful about how you're going to create your histogram. All right, I won't bother you anymore, and we're running out of time. So I think on Thursday, things will become clearer. And if not, definitely make sure to come back to this part of the area principle, as well as like just thinking hard about how to compare a histogram to a bar chart, and then how they're different, how they're similar. And then of course, you will see that in order to get to a histogram, we have so many intermediate steps, just like the bin-in, right? And later you're gonna see even more in order to create a histogram. Okay, so there are many things going on, so just keep it in mind. And I hope you will find it more useful later as we get the detail a little bit more clearer. And then histogram is a very useful visualization method for numerical data. Okay.
Computer. All right, happy Thursday, everyone. So we're gonna pick up where we left off last time, where we started talking about histograms. In particular, we talked about kind of what histograms are, and histograms are really designed for showing distributions of numerical variables, and contrast that to the bar plot, which was a good way of showing categorical values. And so the key with histograms, and one of the big primary differences from bar charts is that histograms uses bins. And so since we're dealing with numerical data, we can bin that data. And there's going to be one bar corresponding to the bin. And unlike a bar chart, the size of the bin, so the how wide these bins are, is up to us, and the bins don't have to be uniform. We can bin however we like. But when we have, it's in particular to pay attention when we have uneven bins, that in histograms really use this area principle, where the area of each bar, so the area, and so that's the height times the width. If you take the height of the bar, multiply it by the width of the bin, that will give you the percent of individuals in that corresponding bin. Okay, and that's and that's kind of important. And we saw kind of from last time that gives us a good visual representation of the distribution from there. Okay. So now that we have this idea that the area represents the percent of individuals, we should talk about how do we calculate the height, and what does that mean in terms of the density of the distribution. And so by default, so if we use the built-in hist method on tables, it's going to normalize. It's going to have a normalized scale, and what that means is that the area of the chart sums up to 100. And so again, that comes back to this idea that the area under each bin corresponds to the percentage of the entire group. And if we're talking about percentage, we would like the whole thing to add up to be 100. The horizontal axis, as we said before, they don't have to be equal to each other. They can be. And because we're kind of dealing with this in terms of thinking about these things in terms of area, the vertical axis, so the y-axis, is going to be percent per whatever the x-axis is. And so in these graphs that we're looking at down below, that's going to be in percent per year. Okay. So how do we calculate the height? Well, it comes from the fact that, so looking at the kind of movie example, and I'll show you a demo of that in a second. If we have a bin, and remember the way we calculate bins, right? This is the thing that is easy to trip people up. And it takes a very Python-centric view. Insofar as that the starting bin, right? So I've shown in this example here, we have this bin denoted from 40 to 65, and we're using the range notation. So the square bracket means the start of our bin starts at 40 and is inclusive of the number 40. And so this particular bin starts at 40 and goes up to, but not including, 65, shown by the parentheses, right? So that's not like a typo. That means that the bin, all of the items in that bin will be greater than or equal to 40 and less than 65, okay? And so to calculate the particular height of a bin, so we can count the number of items in that bin. And so for this movie example that I'll show you a demo for in a second, this bin has 52 out of 200 movies, okay? So the percentage in that bin is going to be 52 out of 100, or if you just do the math, that's 26%. And so we want the whole thing, we want the whole area of that bin, of the area of that bin to represent 26%. So to calculate the height, we're going to take this 26% and we're going to divide it by the width of the bin. And in this case, the width of the bin is 65 minus 40. That gives us 25 years wide. Okay, so the height of the bar, if we were plotting this out, and the good news is here, I'm kind of walking you through the mechanics to show you what the histogram method does, but it will do all of this automatically for us. And so the good news is we don't have to do all of these calculations, but it's good to know where these calculations come from. So we're going to take the 26%, so that is the area that we want to represent, and then we just take the width. They take the width of the bin itself, and we take the 26 divided by 25, and then that's going to give us the height, which represents 1.04% per year, okay? And then if you multiply that, the height, by the number of years, 25, that gives us our 26%, our area for that bin. Okay, another way to kind of look at that is that thinking about height in terms of density. And so kind of from our formula, height of bar is our percent over the years. We can just kind of rearrange for height. And so if we look at the height, what does the height represent? The height represents the percent in the bin over the width of the bin, right? We kind of went over that on the last slide. And so the height, the way you kind of want to, the one way of thinking about the height is it measures the percent data relative to the amount of space in the bin, okay? And another way of saying that, the way you can think of the height is that how crowded is that bin? How, in other words, how dense is that bin? So the higher the height, the more items are in that bin, they're going to be more crowded together. And so one way to think about it is that the area represents the percentage, the height represents density of that bin. And again, the units of height are percent per unit. And whatever the unit is described on the x-axis. Okay. And we talked about this, and just to kind of have it in reference form, the area is simply the height times the width, and that's going to be the percent. And so if you're asking yourself, the question, well, how many individuals in the bin? Well, that's an area question, right? That is the percent over the total. But if you want to ask yourself how crowded is a particular bin, you can get that just looking from the height. All right, let's take a look. Let's take a look at that and see an example. Any questions so far while I'm getting the demo up and going? All right, and I remember to make the Jupyter Notebook big this time. So hopefully everyone can see that. If it's still too small, say something in the speak up or pop something in the chat, and I'll make it a little bigger. But I think this was what we used last.
Just a bit bigger.
You want to make it a little bit bigger?
Yes.
No problem. How's that?
Perfect.
Awesome. Okay, 175% is our default going forward. Fantastic. Thank you. Okay, so let me center this. Okay, great. So import of all of our stuff. And so here we're going to read the top movies from 2017. And so now we have that table. We can look at that real quick. So we have titles, gross, and year. And so what we want to do is for this demo, we really want to look at the ages of movies. And so this year, this list came out in 2017. So let's take the ages of the movies from 2017. And so we're going to make our own table. And so we can do that by extracting the year column from our table. And we're going to make a new array. Subtracting the year that the film was made from 27, and that will give us the age of the film in 2017. Okay, and then we're going to add it back. We're going to add it back to our table. And so if we do that, a new column automatically appears, and that's going to be the age of the movie, right, relative to 2017. Okay, so that's all review. And so now we're going to look at this in a histogram. And so whenever if you want custom bins for a histogram, you're gonna need to make them yourself. And you can do that with the make array method. And then it's just the list of the bins. And again, the way you want to kind of, as a review, the way you want to think about it, the first bin is going to start at 0 and go up to, but not including 5. The second bin starts from 5 up to, but not including 10, all the way up to the bin at the end is going to be 65 up to, but not including 100. Okay, so we'll make those bins as an array. And now we can call the bin method on our movies table. And so the first argument there, age, is what we want to bin on, right? So that's going to be our newly created. And the bins that we'll do are my bins. If you leave this last part off, it will try to guess what bins you think you might like from there. Okay, so if we do that and we take a look at our bin data, and so notice, right, Monica talked about this on Tuesday, but kind of one of the quirks of it is that you get this last bin here. Okay, right, so the last bin that has like any width is from 65, but up to but not including 100. But when we look at the bin data here, it's going to show you that last table. It's going to show you that last bin, but there's not going to be anything in it from there. Okay, so that's just something to kind of be aware of. When you kind of look at the counts for the bins, right? So we called the bin. So now we've actually got the counts for each of those bins as we specified. Okay, and so we can now convert that. We now can convert that to a percentage. And so since we have the counts, to convert that to a percentage, we're going to add a new column, %. And so we're going to take our bin data and our age count, which we have there, and we're going to divide it by the total. And so how do we know what the total was? We can see from this table here, right? Remember, because this is the accounts from the original table, and you can see it shows the first 10 and that there's 190 left. So there's 200 in that column there. So we're taking that and we're taking our data and dividing it by the total number of count, and that's going to give us our %. Okay, and if you want to see that, we can see now we've added a column. We've added our column to our bin data table, and so now we have a % from there. Okay. All right. So now that we have our percentage, let's actually look at the histogram. Right. So the histogram method on tables will actually show the histogram for us. The first column is what we're going to do the numerical data that we're going to do the histogram on, and so that's our age, and we're going to use our bins, and this unit is just going to be useful for when we plot out the title. This is going to show up on the axes here. So now if we run that, now that is creating the histogram with our custom bins, that we've shown. And the unit here, right, shows up in the percent per year and the age per year, right? It's really just a string you could put, you should put the unit, but if I just put, you know, hi and rerun it, it's just going to show you it's in units hi. It's not doing anything with the unit parameter other than, whoops, other than updating the title for us. Okay. And comparing that to our bin data, you can see the age counts and the percents, and then, but notice, right, the percent per year, right? So it's taking each of these bins, bin percentages, and it's spreading it out across the width of the bin. And that's why the unit, that's why the y-axis is percent per year, okay? And so if you actually wanted to get the actual percentage, you're gonna take the, height here and multiply it by the width. And so let's see a particular example of that. And so if we look at the data where the bin is 40, okay, so we're going to look at this column here and take a look at that percent. You can see that 26% of the movies are in the 40 to 65 bin, okay? And you can actually see that from this table right here by looking at the 40 line. And then the width of that particular bin is going to be the start minus the end minus the start. So the width is just going to be 65 minus 40. And then the area, the height is going to be the percent divided by the width. In that case, it's going to be 1.04. And if you look at that graph here, you can see it is, if you look at kind of the 1, it's just above the 1. And so that looks like that all kind of checks out. If you look at just showing the bin data again, and the number of rows, you can see that, again, that last row here is kind of like the end row. If you wanted to get the width of each of the bins, we can use what showed up in I think the last homework you have, the diff method. And that's going to show you the difference between all of the different, it's going to show you the diff between the columns. And so if you do that, you can see that it's gotten rid of that end, and the widths column themselves actually has all of the widths, okay? And so if we want to calculate all of the bin data themselves, what we're doing here is we're creating our bin data minus 1. So we're creating an array of all of the leftmost bins. And then we're just going to take that data there. And then if I show you this, that gets rid of, this gets rid of the last bin here, and then is just showing the start of each of these bins, right? So each, it's showing the start of all of them and getting rid of that last bin. So the bins in our particular graph start at 0, 5, 10, 15, 25, 40, oops, down here, 25 and 40, okay? And then now that we have all of the starting bins numbers, we can just simply divide to get the heights. We're going to take the percent and divide it by those widths. And then what went wrong here? Oh, no. Okay, good. And here's all of our bin data with the particular heights associated with it. And then just kind of putting it all together. that's where we come up. So bins or 5 age count and then 15. Wait. Oh, something. Hold on. What happened? What did I? Oh, give me one second. I overwrote my data. Restart and run all. Let me. Okay, that is much better. This is in this over here. I overwrote my bin data, so that was throwing off these graphs up over here. But putting everything all together, here are the manual heights that we collected, and if you compare them to the actual histogram, they all line up. And so again, kind of the takeaway is that we're calculating the heights which represent density. The height times the width gives us the area, the percentage of individuals in that bin. And we kind of work through in this example how to calculate those heights. But the good news is that the histogram method will do that automatically for us. But it's helpful to kind of walk through all of the steps in there just to kind of remember what's going on with them. So the width, the area represents the percentage, the height represents the relative density in that bin, right? And so you can see this is a very crowded, the first one from 0 to 5, that's a very crowded, it's a very crowded bin. There's a lot of movies relative to the size of the width of the bin. And down here at the end, it's relatively sparse from there. Okay. Any questions about that?
I was wondering why the last bin is showing as a result, whereas in the table that you showed us in there, the 100 didn't have any individuals in it.
So so up here, this one right here,
Yeah.
in 12, or further down.
Yeah, this one shows that the
Yeah. So
bin-
this is kind of and thank you for asking. It's kind of worth highlighting. It's kind of the way I think of it is it's kind of a quirk with the histogram method. And so the way the library works is that, so let's kind of think about what that last bin is from here. This last bin starts at 65 and goes up to, but not including 100. But it's showing the way it works for plotting is it's actually showing the next bin, the starting point of the next bin, because of the way it's defined. When you want to calculate the width of the bin, you're actually looking at a difference. And so it's important that we actually know where that bin ends. And so it's showing the 100 as really the end point for the previous bin, but it's there and it's going to show up as a bin, but it's a bin with 0 width. Okay. And so you're not going to see any items in it. For all practical purposes. And so, I kind of view it as a quirk with that. I don't know if that answers your question in a satisfyingly manner.
So if we have other tables that we're working with and they have 0, would that happen as well?
What do you mean for tables?
I mean, we have all of this data and we have a bin that we're trying to show that has 0 individuals in it. Will that also happen in another exercise?
You mean at the end point?
No, not at the end point. Like if it's in the middle, for example.
Oh, I see.
Will it show like something, or will it be completely empty.
Got you. Yeah, yeah. So if for example, if the bin from like from 10 to 15 didn't have anything in it, it would show up empty. It would show up as a gap in the histogram.
Thank you.
Okay. Let's go back from there. All right. I think this wraps up this topic. So I'm gonna